Here we have a plan view of a natural system, something like the Macquarie River probably used to be approximately 200 years ago at the point of human settlement. A system where everything's in sync. As you can see, we have pools occurring on the outside bend, and we have here and there, and then we have these systems here which we call point bars, which are usually accumulation of sand and gravels. We also have native vegetation, trees and shrubs growing on the outside bend of the river or creek, stabilising that bank and providing shade and a food source for those pools. We have native reeds growing here as well, which also provide a function for filtering water, which increases water quality. So something that's really good and in sync. As we go to the cross section here, I've drawn, this is a cross section through a pool. As you can see, we have the big trees here, we have grasses and shrubs. So what happens here is they can drop leaf into the water all through the year at a low rate. So this provides a food source for things like native fish and other crustaceans that live in the water. I've also drawn in here some native hardwood or trees, like native trees that have fallen in there. We call this large woody debris. So this is very important for native fish numbers and usually have a direct association between the amount of large woody debris and native fish in the system. Why these are so important is that native fish actually use them as a food source, so they eat there. They also lay eggs on the trunks there and breed, but they also can hide and live in these assemblages to escape predators. So very important. So as we come back to our plan view here, as willows are introduced to the system, they can start growing usually along the banks, but they also have the ability to start growing within the water columns, so they can grow across the stream and to form islands and things. Now willows are classified as a weed of national significance, and by that, and why it's classified as a weed of national significance is its ability to spread and propagate, form monocultures and outcompete all other species. So just as an example, if willows grow in there and a branch falls off, it can float downstream. It can possibly stop here on the edge of this point bar, and it can actually then start growing to a new tree and the whole system starts again. So a fair issue. So if they start to grow within the stream, within islands and on the banks, they can actually start to slow water down as it's moving through the system. As this happens, sand and silt will start to fall out of solution or out of the water and start to deposit within these pools. So as we go back to the cross section, I've actually drawn that in. So this is the sediment starting to fill pools up, and as you can see, it's starting to bury some of this large woody debris. The issue with willows as well, is I've drawn them here in orange, is that they're a deciduous plant. And by deciduous, I mean they drop their leaf in autumn, usually over a period of 1 to 3 weeks. Why this is important is that we basically get a large accumulation or biomass of leaf in the water at one point in time over that 1 to 3 week period, which actually causes a process in terms of deoxygenating the water. So we use a lot of oxygen in the water to actually try and break down that. So this is not good news for native fish because they actually rely on high amounts of oxygen in the water, and they rely on these assemblages of large woody debris to breed and live within. So things like feral fish species like the European carp become more abundant because they're more adapted to these environments. If we go back to the plan view, one of the last issues with willows is that they actually, as they grow in the banks and across streams within islands, they'll actually start to, water will slow down, but will start to move around the outside as well to its weakest point. And when that happens, it actually starts to erode the riverbanks, which is not a good outcome either.